So, last lecture we have seen the input bias current, right. This lecture let us concentrate on input offset current. So, we were able to measure the input bias current. I have shown you the table where you can measure V plus, which is voltage at inverting non-inverting terminal, then we have seen V minus, voltage at inverting terminal, then we have understood how we can calculate IB plus and IB minus, and then mode of IB plus IB minus divided by 2, that was your input bias current. Now, in this particular class we will see input offset current and what exactly input offset current means. So, again if you guys remember the circuit for the input bias current, the same circuit we can have for input offset current. So, the circuit was, we have a resistor, we have plus VCC, minus VCC or minus VEE, right, plus VCC, we have output voltage minus VEE or minus VCC, we have both the terminals ground, right, both the terminals ground. Now, this was about 220 K, inverting, non-inverting, this was the circuit, right, if you remember. So, now same circuit we have to use for understanding the input offset current. So, what exactly input offset current means? So, the difference in the magnitudes of IB1. So, in that we were adding it, right, we were adding it and divided by 2. Here we have to take a difference of what? Difference in the magnitudes of IB1 and IB2 is called input offset current. So easy, extremely easy. Why? Because we have to just measure difference, right, and is denoted as input offset current. You have to remember, okay, input offset current is denoted by I in the subscript IOS. Now, thus input offset current IOS equals to mode of IB1 minus IB2, right. Again B1 and B2 would be in subscript. The magnitude of this current is very small, order of 20 to 60 nanoamperes, it is extremely small, and it is measured under a condition that input voltage to the op amp is 0, right. So, what is input voltage? Guess what is input voltage right now? Nothing, right. So, input voltage is 0. So, this is the perfect condition where we can measure what is the input offset current, right. So, quickly again, the difference in the magnitude of IB1 and IB2 is called input offset current and is denoted by IOS. Thus, input offset current is nothing but difference of or magnitude of IB1 minus IB2. The value is close to 20 to 60 nanoampere. So, if we apply equal DC currents to two input, output voltage must be 0, this is obvious, right. If we apply equal current, output voltage should be 0, but practically there exists some voltage at the output. So, that means that if I ground both the terminals, I will see some voltage at the output even when we apply similar current to the input terminals inverting and non-inverting, I will still see some output voltage in the output. Output we can measure the output voltage, like how to measure the output voltage? We can measure the voltage here. So, to make it 0, what to make it 0? Output voltage, right. The two input currents are made differed to by small amount, this difference is nothing but the input offset current. So, the point that we have to remember is when we apply equal DC currents to the input voltage, to both the input voltage, right, what are input voltages? Inverting and non-inverting, then output voltage should be 0, VO should be 0, but in reality this is not 0. So, what we can do? We can differ the input current by small amount. If we differ the input current by small amount, the output voltage will become 0. Now, this is what we want. Why we want equal to 0? Because we are not applying any voltage, we are applying equal current, then output should be 0, right. This is how we are balancing our amplifier. It is very important that you balance your operation amplifier before you start working on different kind of circuits, alright. So, let us see now on the breadboard how we can connect this and how we can measure the input offset current, alright. So, for this again we go back to the this particular table, right. And here what we are looking at input offset current. If you remember, we have in the last module we have seen input bias current. Here we are looking at input offset current. Input offset current is IB plus minus IB minus, right. The input by bias current at the non-inverting terminal minus input bias current at the inverting terminal. Now, we already know input bias current, how we can calculate, right, how we can calculate. So, let us see once again, if we connect it. So, there is a breadboard here, again you can see the breadboard, right. So, here what is there? There is a integrated circuit which is your operational amplifier, and there are two resistors 220K, right, this 220K, these resistors are there. Now, we have applied the bias voltage to the operation amplifier. How we apply bias voltage? By applying plus 15, right, minus 15 across the 7 and 4, right, 7 plus VCC, 4 minus VCC or VEE. Now, inverting, we have to measure voltage at inverting terminal, we have to measure voltage at non-inverting terminal. So, let us see, we got the multimeter which you have seen in the last module, right, this multimeter, and we have measured a lot of things using this multimeter. So, let us see what is the value in this multimeter. So, can you please check the voltage at the inverting terminal? Yeah. So, the value is 6 millivolts, 6.1 millivolts, 6.1 millivolts, alright. This is at inverting terminal. Let us see at non-inverting terminal. It depends how you connect it, okay. Your hands should be stable. 6.3 millivolts, good, alright. So, 6.1 and 6.3, we got two values, right. So, let us write this 6.1 and 6.3 in our table. So, if you see the table, your values are 6.1 and 6.3, 6.3, 6.1. Using this value, can you calculate IB plus IB minus? Yes. Once you calculate IB plus IB minus, you have to take the difference of IB plus and IB minus, and then again you see it is a mode, it's a mode. So, this is how you can calculate the input offset current, right, easy. But let us see, if I give you an example, theoretical example. For example, you say that Hardik, I cannot get the values because I do not have the operation amplifiers, I do not have the DC power supply, I do not have the measurement systems like multimeter. Can I still calculate the input offset current? Can I still calculate input bias current, right? So, theoretically you can. So, for that let me give you an example, alright. So, if we focus on screen, this is an example. What is the example? That if the base current for the emitter coupled transistors of a differential amplifier are 18 microampere and 22 microampere, we have got two values determined, one input bias current and 2 input offset current for the operation amplifier. So, given the values of IB1 which is 18 microampere, IB2 22 microampere, can you now calculate input bias current and input offset current? Is it easy or not? Extremely easy, right, because now we know the formula. So, let us see the first one which is input bias current, right. I will give you the answer. The input bias current is nothing but IB equals to mod of IB1 plus IB2 divided by 2, 18 plus 22 divided by 2, we get answer 20 microampere. Super easy, right. Now, let us see the second one which is your input offset current for an operation amplifier. So, for that input offset current, everybody knows what is the formula, IB equals to mod of IB1 minus IB2, right. If we put this value again, 18 minus 22 would be 4, again it is a mode. So, not minus 4 microampere, do not get this value, it is wrong, right, it is mode. So, it will be even 18 minus 22 is minus 4, it is a mode. So, we get a value 4 microampere, easy. So, this is how you can calculate the values even at home, right. Take a problem and solve it, right, solve as many problems as you can, then go to the laboratory or get a multimeter at home, a small multimeter, a DC power supply, right, and you can have a small lab at home. You do not really require to go to the university, go to the college and learn something, right. You can learn from anywhere, any place. That is the idea of the learning, right. Learning is not restricted to a particular building, learning is not restricted to particular lab, learning is not restricted to particular college, learning is not restricted to particular university, learning is not restricted to any books also, right. Learning can be done anywhere if you want to learn, and this is the way you can learn. Use internet, right. Take the NPTEL courses, learn, right, understand, and then out of your curiosity ask questions. Before you ask questions, you should try to answer this question by yourself, try to see, right. Do not rely on spoon feeding. That is always my one sentence I tell you again and again, do not rely on spoon feeding, right. So, this is how we can measure the input offset current, and we can measure the input bias current. So, in the next module we will see the another experiment or another characteristics of an operation amplifier. Thank you.